All right, we're going to do something called completing the square. It's a little bit weird, but it is extremely valuable when you're dealing with quadratics. So I'm going to start off with two binomials that need to be squared. Okay. If I multiply these out, I get x squared minus 4x minus 4x plus 16, which becomes x squared minus 8x plus 16. And same thing here. This is going to end up being x squared plus 12x plus 36. Do you see a shortcut to go from here to here? Where did the 16 come from? 4 squared. Where did the negative 8 come from? 2 copies of negative 4, right? Does that pattern hold here? 6 squared, and the 12 is just 6 plus 6. So if I had x squared minus 14 plus 49, does that fit the pattern? Oh, if I put an x in there, it does. That would be x minus 7 and x minus 7. That make sense? Okay. Well, we can actually use that to solve problems that are not perfect squares. So let's say x squared minus 10x plus 11. Does that fit the pattern? No, it doesn't. So let's pretend that it does. So, excuse me, I'm going to move this 11 out of the way. So we get x squared minus 10x, and I'm going to leave a blank, equals negative 11. Okay, so if this was a perfect square, what would go inside the parentheses? Minus 5. Okay, and if this is a minus 5, what number would be there? A positive 25. So this would be plus 25. Now, am I allowed to just add 25 to one side of the equation? No, I have a balanced equation, and adding 25 pounds to one side makes it unbalanced. However, if I add 25 to the other side, now it's balanced again. So I'm going to put plus 25 over here. And now that becomes 14. Ooh. Plus 11. Oh. Oops. I did that wrong in my head. I'm sorry. I actually wanted a 9 over here. Okay. So negative 9 plus 25 is 16. And now I can solve. Square root this, square root this, square root and the squared cancel, and I get x minus 5 is equal to... Some of you aren't paying attention to this. You're really going to want to see this. This is kind of important. So what does that equal? Not 4. Kind of 4. It's a 4, but it's also negative 4, right? Anytime you square root an x squared, you have to put plus or minus 4. Now we add 5, and you can't just say plus or minus 9. It doesn't work that way. 4 plus 5 is 9, and negative 4 plus 5 is 1. And that would have been my answer had I factored this. Two numbers that multiply to be 9 and add to be 10. That would be x minus 9 and x minus 1. And then I write equals 0 on each of those. And I get x is equal to 9 and to 1. That is called completing the square. So let's do another one. Some of these are going to get pretty tricky, so pay close attention. X squared minus 6x minus 16. Is that a perfect square? No. So can I factor that into x minus something squared? Not yet. So I need to complete the square. So I move this 16 out of the way. X squared minus 6x, leave a space, equals 16. And I need to figure out what number goes there so that this can be a perfect square. And the pattern is cut the middle number in half and then square it. So cut the middle number in half would be x minus 3. And 3 squared is 9. So I add 9 to the other side, and I get 25. Okay. Now we take the square root. X minus 3 is equal to what? Positive and negative 5. So plus or minus 5. Add 3. We get x equals 5 plus 3 is 8. Negative 5 plus 3 is negative 2. So my answers are 8 and negative 2. Now, would that have factored? Yeah. So x minus 8 and x plus 2, and that's where those answers come from. Well, if it is already solvable, why would I bother learning completing the square? Because completing the square will work even if the equation does not factor. But first, let's do a couple more. X squared minus 3x, let's say minus 18. This one's going to be much harder. So is this a perfect square? No. But if it is a perfect square, it will have a minus on the inside. So let's move the 18 out of the way. X squared minus 3x, leave a space, equals 18. What number here completes the square? And this is kind of tricky. Well, the number here is half of negative 3. Half of negative 3 is negative 1.5. However, I bet you cannot do 1.5 squared in your head. So leave it in fraction form. So instead of writing 1.5, we're going to write 3 over 2. Okay? And then negative 3 over 2 times negative 3 over 2 is easy to do in your head. It's just 9/4. So over here, I need to add 9/4. Well, what is 18 in fourths? 18 times 4 is 72. So this becomes 72 over 4 plus 9 over 4. 72 plus 9 is 81 over 4. Now I square root. X minus 3 over 2 is equal to, the square root of 81 is 9, and the square root of 4 is 2. Plus or minus. Add 3 over 2. 9 plus 3 is 12, divided by 2 is 6. And negative 9 plus 3 is negative 6 divided by 2 is negative 3. And those are my factors, or those are my roots. All right. Let's do some of the assignment and see if any of them turn into more difficult problems. What number there completes the square? Well, in order to complete the square, it would need to look like this. what number would go in here if that is an 8? Well, this number would be 4. And in order for this number to be 4, there must be a 16 right there. And that is the number that completes the square. So we have taken a partial quadratic equation and we've added a specific number that turns it into a perfect square trinomial. Like that. Let's see if they're going to give us an odd number. I doubt they will. So this would be y minus 6 squared, which means this would be 36. The perfect square would be y minus 1 squared, which means the number needed to complete the square is a 1. Okay. All right. Okay. So one way to graph a quadratic equation is to use this form, x minus h squared plus k. And the vertex of the parabola is h comma k. But notice, in the equation, the h is negative and the k is positive. So the number on the inside goes in the opposite direction, and the number on the outside goes in the correct direction. So anything that happens to the x moves it left and right, and anything that happens outside the x moves it up and down. So this parabola has a vertex at -4, 3, and then it wants 2 points to the left and 2 points to the right. Well, 1 squared is 1, so we go over 1, up 1, over 1, up 1. And 2 squared is 4, so we go over 2, up 1, 2, 3, 4. Over 2, up 1, 2, 3, 4. Okay. All right. What if it said y equals x minus 2 squared plus 5? So that would be right 2, up 5. And then the pattern is over 1, up 1, over 1, up 1, over 2, up 4, over 2, up 4. Oh, right there. And that's my parabola. What if this was negative? Then we would do the same vertex, over 2, up 5. But now instead of going up, we do over 1, down 1, over 1, down 1, over 2, down 1, 2, 3, 4, and then over 2, down 4, and the parabola opens downwards. All right. So what is the difference between y equals x squared, y equals 2x squared, y equals 3x squared, y equals 1/2 x squared? So all of these coefficients are happening outside of the x, which means they're going to affect the y-axis. So this is my regular opening parabola, over 1, up 1, over 1, up 1, over 2, up 4. This one is 2 times taller. So instead of over 1, up 1, it's going to be over 1, up 2. Over 1, instead of up 1, it will be up 2. Now, that appears to look skinnier, but skinny is not the proper description of this. The parabola got taller. And yes, it also got skinnier, but the movement we performed was taller. And it turns out that taller and skinnier actually have two different mathematical calculations. They appear in different places. So this one would be 3 times taller. So instead of over 1, up 1, it's going to be over 1, up 1, 2, 3. And then my next point, instead of over 2, up 4, it's going to be over 2, up 3 times 4, so 12. So that's going to be much taller. And then this one is going to be half as tall. So instead of over 1, up 1, it's over 1, up 1 half. And over 2, instead of over 2, up 4, it's over 2, up 2. So you just need to match each graph with each description. So A is negative, and choose the coefficient that's, oh, I see. So the smallest coefficient is going to be the shortest graph, which is C. And the coefficient with the greatest value is going to be the positive that is the tallest, which is going to be D. All right. So here, if we started with the absolute value of x, and we move the graph 4 units to the right and 2 units down, the x change is 4, and the x change works backwards, so x minus 4, and the y change was negative 2, so it's just going to be x minus 4 on the inside and minus 2 on the outside. Okay, this one moved 2 to the right and 3 down, so x minus 2 is the shift to the right, and then minus 3 on the outside is the vertical shift. Oh, that's not what I wanted. All right. So I want to solve this by graphing, but I'm not allowed to use a graphing calculator, so I need to complete the square. Now this is going to be just slightly different than the completing the square that we did earlier. So x squared plus 6x plus 5 equals 0. And when I was solving, I moved this to the other side. And when we graph, we want all of the values to be on the same side. So x squared plus 6x, I'm just going to leave a space and then put plus 5 equals 0. Okay? So what is the perfect square in this case? Well, it would be x minus 3. And if we have x minus 3, what number belongs there? 9. And that's going to make my equation heavy on the left. But I don't want anything on that right side. I want it to remain 0. So instead of putting a plus 9 over here to counteract this 9, I'm just going to put a minus 9 right here, so that essentially I added 0. So putting the plus 9 made the left side heavy, but then I removed 9, and now it's all balanced again. So that gives me x minus 3 squared. 5 minus 9 is negative 4. And now I know where the vertex is. The vertex is going to be 3, negative 4. So right 3 and down 4. That's my vertex. And the leading coefficient is a 1. So it's over 1, up 1, over 1, up 1, over 2, up 4, over 2, up 4. And then when I draw that parabola, it will tell me where it hits the x-axis. Okay, let's do another one. That's the exact same equation. Okay. So x squared plus 2x, I'm going to leave a space, plus minus 3 equals 0. my perfect square will be x plus 1 squared. But in order for x plus 1 squared to exist, I need a plus 1 here. And that makes the left side of the equation heavy. So I could add 1 to the right side, but I don't want to. I just want to subtract 1 on the left side. And now this becomes that, and that offsets the 1. And I get x squared plus 1 equals negative 4. And that tells me where the vertex is. The vertex is 1 on the x and negative 4 on the y. And then I need 2 points to the left, so over 1, up 1, over 1, up 2, or sorry, up 4, over 1, up 1, over 2, up 4. And when I draw that graph, my solutions are negative 3 and 1. Okay, let's do one more. All right, x squared plus 10x, leave a space, plus 21 equals 0. So this would be x plus 5 squared. And in order for this to be a 5, that needs to be a 25. But if I add 25 there, I need to offset that 25 by subtracting 25. And I get negative 4, or not equals, just minus 4. So my vertex is negative 5, negative 4. And then the pattern is over 1, up 1, over 1, up 2, over 1, up 1, over 1, up 2. And those are my solutions. All right. What is the equation here? Well, the equation for a parabola in vertex form is y equals a times x minus h squared plus k. So I do know h, negative 5, and I do know k is negative 2. So I can fill those in. Y equals a times x plus 5 squared minus 2. And that gives me the position of the vertex, but I need to know how far, or what is the leading coefficient. So I look here, over 1, down, I'm not sure how much, a little bit, but over 2, down, I don't know. It's kind of hard to tell from the graph. So I'm going to take this other point, and I'm going to plug negative 7 in for x and negative 10 in for y, and that will leave me with an equation that only has one variable, and then I can solve it using algebra. So negative 10 equals a times negative 7 plus 5 squared minus 2. Negative 7 plus 5 is negative 2. Square that and I get 4. So negative 10 equals 4a minus 2. Add 2 and I get negative 8. So a is negative 2. So the equation of this parabola is y equals negative 2 times x plus 5 squared minus 2. And I mean, it kind of looks like it. It was hard to tell from the graph that it was going to be negative 2. I thought it was going to be a fraction. All right, let's do another one. All right. Okay. So I'm going to plug in the vertex. Y equals a times x minus 2 squared minus 5. And this one I can actually tell is over 1, up 1, 2, 3. So I know that number's a 3. But just in case you don't know, let's solve it the other way. I'm going to plug 3 in for x and negative 2 in for y. So negative 2 equals a times 3 minus 2 squared minus 5. 3 minus 2 is 1. 1 squared is 1. So negative 2 equals a minus 5. Add the 5. A equals 3. Now I can put this into that equation to finish it out. Y equals 3 times x minus 2 squared minus 5. And that's it. All right, get to work.